Suppose we have this binary search tree and in which we need to find the element 45. What we need to find? We need to find element 45. So we can simply say, because in binary search tree at every node, root is always greater than all element present at left hand side. We can simply see from here, root is always greater than or equal to element present at left hand side. From here root is greater, 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 that is 55. You can simply see. So this is the binary search tree. What is the next condition? The next condition is that at every node, root is always less than or equal to all element at right hand side. Because see from here, right hand side element is greater than the root, right hand side element is greater than the root, right hand side element is greater than the root. So these are the two conditions which belongs to the binary search tree. So if we want to find the element 45, so only 4 comparison will occur. Only 4 comparison will occur. How? Out of 50, there are total 50, how many nodes? 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So total 15 nodes are present. So only 4 comparison out of 15 nodes. How? We can understand, because total 15. So 15 divided by 2, so 7. Middle element we are calculating. 7 divided by 2, so 3, and 3 divided by 2, so we will get that element. We will reach the element. So in that way, only 4 comparison will occur if the tree is binary search tree. Because we can simply say, because it is an balanced tree. It is an balanced tree, and we know where we need to go, from left hand side or right hand side. Whenever we get the middle element, we know where we should go, because this is a balanced search tree. But if suppose tree is like that, 10, 5, 3, 2, 1. Suppose if it is like that, so we can simply say this is not balanced tree. This is not a balanced tree, or we can say balanced binary search tree. Not balanced binary search tree. So that's why it will take more time. So it will take more time to search an element. So this is the difference between the balanced binary search tree and the unbalanced binary search tree. So suppose if we want to calculate how many search trees are possible with n nodes. How many search trees are possible with n nodes? We want to calculate n nodes, or we can say the vertices. So how we are going to do this? Suppose if we have 2, like 1 or 2, so only 2 binary search trees are possible. 2 binary search trees are possible. How? We can say simply like this or this. But if we have n is equal to 3, it means 1, 2 and 3. So how many are possible? Possible 3, 2, 1, 2, 1, 3, 1, 2, 3, 1, 3, 2, or 3, 1, 2. So total here is 2 and here 1 2 3 4 5. 5 possibilities are there. Like that, if we calculate, so n equal to, if n equal to 4, it means 1 2 3 4. So we can simply say, we can write like this: 1, that is 1 into 5, 5. How? 1 and 2 3 4. 5 possibilities are there. How 5 possibilities are there, I'll let you know. Let's understand. 1 2 3 4. This is 1, and 1 3 4 2, or 1 4 2 3, or 1 4 3 2, or 1 2 4 3. So like that, we can understand 5 possibilities are there. If we put 1 and 2 3 4, so 1 into 5, 5 possibilities are there. So 5 I have written here. Like that, if we go by, suppose 2, and so always 1 will remain here, and what is left? 3 4. So it will be 1 into 2, that is 2, because we know when we have only 2 nodes, so how many trees are possible? When we have 2 nodes, so 2 trees are possible. That's why we have right here 2. So now come to the next. If 3 is a node, then how many possibilities are there? 1 or 2 will come here and 4 will come here. So 2 possibilities are there. So only 2 into 1, 2 nodes are there. And in the similar way, if 4 is here, then 1 2 3, 3 nodes are there. So total 5 into 1, that is 5 into 1, that is 5, as we have seen for the 1, when 1 is there, and 2 3 4 were that side. So as we have calculated for 1 is there, and 2 3 4 are that side. So 5 possibilities are there. So in the similar way, if 4 is here and 1 2 3 is here, then 5 possibilities are there. So we can simply say, if 4 nodes are there, so how many possibilities are there? 5 plus 2 plus 2 plus 5. 5 for when 1 is on the when 1 is root and all things are, all elements on the left right hand side. So in that way, total how many? 14 binary search tree are possible. So like that, if n is equal to 5, like that, if n is equal to 5, so it means 1 2 3 4 5. So how many elements are there? 1 and 2 3 4 5. So as we know, total how many? 14. 1 into 14, that is 14, because for 4 elements 14 BST are possible, binary search tree are possible. In the similar way, if 2 is there and 1 3 4 5, so how many? 5. 1 into 5, that is 5. 1 into 5, that is 5. And like that, 3 is there, then 1 into 2, and 4 5 will be here. So 2 into 2, that is 4. 2 for this, 2 for this, that is 4. In similar way, if 4 is there and 1 2 3 are there and 5 are there, then 5 into 1, that is 5. That is 5. And one more is left, like this. If 5 is there and 1 2 3 and 4 elements are there, though, then how many? 14 into 1, that is 14. So total how many BSTs are possible? If nodes are 5, 14 plus 5 plus 4 plus 4 plus 5 plus 14. So how many? 42 BSTs are possible. So in that way we are going to calculate it further. We are supposing let Tn be the number of binary search tree possible with n nodes, So how we are going to calculate it? Tn is equals to summation of I is equal to 1 to n ti minus 1 into tn minus I. So I minus 1 is root here, or we can say simply left hand side, and this is on the right hand side. How? Let's understand with example. It will be more clear. N is equal to 4. Then if we are calculating 4, T4 is equal to summation of I is equal to 1 to 4. So what it will be, because this is a root element, so and for I equal to 1, then it will be 0. If I is 1, then it will be 0 because it is a root element. Into n minus I, it will be T3. So for T3, how many? If 3, then how many? 5. So 1 into 5, that is 5. And similarly I equal to 2, this is for I equal to 1. Then when I equal to 2, then what will happen? T1, because 2 minus 1, 1 into T2. So what is T2? If there are 2 elements, so how many? 2, 3 are possible. So 1 into 2, that is 2. For 3 elements, how many BSTs are possible? 5. So we have written 5. For 2 elements, how many BSTs are possible? 2. So we have written 2 here. So when I equal to 2, then similar way, if I equal to 3, then T2 into T1, that is 2 into 1, 2 elements. Similarly, if I equal to 4, then T3 into T0, that is 5 into 1, 5 elements. So total how many elements are there? 5 plus 2 plus 2 plus 5, that is 14. So we can simply write Tn is equal to summation I equal to 0, n minus 1, Ti into Tn minus I plus 1. So this is the formula by which we can calculate how many elements are possible. In the similar way, without giving any condition, or we can say without labeling, or we can say unbalanced binary search tree. So how we are going to calculate? We are going to calculate Tn is equal to 2n Cn upon n plus 1. This is the formula. If we take the simple 633 upon 4, then we can simply see 6, 5, 4, 3, 2, 4. So only 5 will left. This will go only 5. So this shows that this is similar. So in that way we can calculate labeled and unbalanced or binary